So I have to take the second derivative. Well, first I'll take the first derivative, though. Okay, find the critical numbers. I'll find the critical numbers, the zeros of the first derivative, critical numbers of the function. Take the second derivative. Okay, do I need to know the critical numbers, the zeros of the second derivative, to answer this question? From the zeros of the first derivative, those critical numbers, I get possible what? Extrema, okay? If I have possible extrema, and I know what the second derivative is, do I need to find zeros of the second derivative? I just need to put what I just found, those zeros of the first derivative, into the second derivative and look to see for what? Whether it makes the second derivative positive or negative, or zero. Remember, we have that option. Now, this one has a little different twist to it. This is cost. What are you asked to minimize? Cost or something else? Average cost per unit. That's not the same thing as cost. It's average cost per unit. So how are we going to determine average cost? And don't overthink this. If I wanted you to find average anything, Casey, help us out. So it would be C of x divided by x. Yeah, absolutely. It's average, right? That's how we find it. So we want to first of all go through and, you know, we might make this 5/10 x plus 15 plus 5,000 x to the negative 1. I'll pause a moment. I took a step out of there. I could have written the step where I take this and divide by x, but then I chose to take x into, divide x into each one of those. Okay? You could use quotient rule. Yeah, you could do that. But again, isn't that much more complicated than using it on this? Now, average cost, you can say AC of x. That's what this is going to be right there. So now I need to find AC prime of x. So I've got here, let's make that a capital A. Let's, you know, think about this. Remember the inspire, if you don't put a multiplication sign between two letters, it takes it as a two-letter variable. Same thing here. We'll just say AC prime, or the derivative of average cost. And, you know, this is going to be that value. Take a moment. Derivative of 1/2 x is 1/2. Of course, the constant's 0. And I take negative 1 times the constant and then our coefficient and subtract 1. Set it equal to 0. Now, because of the nature of this, I think I'll opt to just make it 1/2 equals 5,000 divided by x squared. Kind of going against what I was telling you before, but because I don't have x in both terms, I see no reason to do a product here. I could. Let's see, 5/10 x squared equals 5,000, x squared equals, yeah. How much? Yeah, don't multiply them now. If I'm going to divide by both of those, I know 5. So is it 100 or is it 10,000? Divided by 5/10 is the same thing as 5,000 times 10 divided by 5. Casey's right. Okay, 10,000. So now, if I want to find x is plus or minus. Is 100 the square root of that? So my answer, I have two answers, right? What's x represent? So can I have negative units? Somehow, instead of producing units, I'm going to somehow deproduce? I don't know. Okay, we'll take it. We'll do this real quick here. Take the second derivative. I would have 2 times 5,000 x to the negative 3. If I take the second derivative of 100, did I forget the negative?
Because you had negative 5,000, so when you bring the negative to it.
Yeah. So I have 2 times 5,000 divided by 100 cubed. I want to try and get this done as quickly as possible. My answer is, well, do we need an answer? What are we going for here? So what do you think? Positive or negative? Positive. Therefore, average cost is, well, if it's positive, it means it's concave up at that point. And so average cost is minimized at x equaling 100 units. Okay, so we use it in that way. Okay, let's